So to evaluate the limit, we substitute in 0, we get 0 over 0, so L'Hopital's rule will apply. So we can take the limit as x approaches 0, taking the derivative, which is cosine of 7x times 7, and derivative of x, which is just 1. Then replacing in the value of 0, we get 1 times 7. Substituting the value of pi over 3, we get cosine of pi over 3 minus 1/2 over pi over 3 minus pi over 3. Cosine of pi over 3 is 1/2, so we have 1/2 minus 1/2 for the numerator, which is 0, and the denominator is also 0, so we have 0 over 0, so L'Hopital's rule can apply. So the limit as x approaches pi over 3, taking the derivative of cosine, which is negative sine of x, and derivative of x minus pi over 3, which is just 1. Then replacing in the value of pi over 3, we have negative sine of pi over 3, which is negative radical 3 over 2. And so then that's letter B. Next problem, we find out we have infinity minus infinity. So we'll take the limit as x approaches infinity and multiply by the conjugate. So we're going to multiply by radical x squared plus 6x plus x in both the numerator and the denominator. And simplifying to get the limit as x approaches infinity of x squared plus 6x minus x squared over x squared plus 6x under the radical plus x. And then simplifying, that's the limit as x approaches infinity of 6x over the square root of x squared plus 6x plus x. Substituting infinity, we get infinity over infinity, so we'll be able to use L'Hopital's rule. So we have the limit as x approaches infinity, derivative of 6x is just 6. Denominator, we have 1/2 times x squared plus 6x to the negative 1/2 times 2x plus 6, and then plus 1. Rewriting to have the limit as x approaches infinity of 6 over x plus 3 over the radical x squared plus 6x, and then plus 1. Multiplying by the denominator of radical x squared plus 6x in both the denominator and the numerator. To simplify the problem, we have the limit as x approaches infinity of 6 radical x squared plus 6x over x plus 3 plus the radical x squared plus 6x. And substituting in again, we can say we have an infinity over infinity. So L'Hopital's rule really didn't make this problem any better, so it didn't seem to help. So we'll go back to the problem when we rationalized and not use L'Hopital's rule, but notice that the exponent of the numerator is equal to the exponent of the denominator. And so we're going to look at the coefficients. And the coefficient for the numerator then is 6, and in the denominator from the radical x squared is 1, and then from the x is also 1. So we have 6 over 2, which is equal to 3. The last example, we have infinity to the 0. So we're going to let f of x is equal to the function 1 plus 3 over x to the 4th to the x. Taking the natural log of the function, we can then move that x that's in the exponent into the front as a coefficient. So we have x natural log of 1 plus 3 over x to the 4th. So we'll look at the limit as x approaches 0 then of the natural log of f of x. So the limit as x approaches 0 of x natural log of 1 plus 3 over x to the 4th is equal to 0 times infinity. And then by rewriting the problem, we have the limit as x approaches 0 of the natural log of 1 plus 3 over x to the 4th. Instead of multiply by x, but divide by 1 over x, we'll create infinity over infinity, so L'Hopital's rule can apply. So the limit as x approaches 0, derivative of natural log is 1 over 1 plus 3 over x to the 4th. And then derivative of that will be negative 12x to the negative 5th over derivative of 1 over x, which is negative x to the negative 2. Then simplifying the problem, we get 1 over 1 plus 3x to the negative 4 times 12x to the negative 3 So that's the limit as x approaches 0 of 3 over x cubed times 1 plus 3 over x to the fourth. Then distributing that x to the third, we're looking at the limit as x approaches 0 of 12 over x to the third plus 3 over x. And substituting in the value of 0, then we get 12 over infinity, which is equal to 0. But then remember we did the natural log, so we have to anti-log, so raising to the e. We have e to the limit of x approaches 0 of the natural log of f of x, so we have e to the 0, which is equal to 1. So our answer is 1.